Hello everyone and welcome to another episode of the Ask IoT video series from IoT for All, the #1 publication and resource for the Internet of Things. I'm your host, Ryan Chacon. If you are watching this on YouTube, please give this video a thumbs up and subscribe if you have not already done so. Truly appreciate that. All right, we have Nick Sinas, the head of technology at Ovyl. They are a multidisciplinary product development firm focused on building turnkey design and engineering services to build the products of the future. So this is the second episode that we have done with them. The first one we talked about testing firmware and software. This one we are talking about firmware development best practices. Nick has a ton of expertise here. So if you're looking to learn more about firmware, what it is, how it works, how to develop it correctly, and things to look out for as you are working potentially with a company to develop it, this is the perfect episode for you. So all in all, fantastic episode. I think you'll get a lot of value out of it. So please enjoy this episode of the Ask IoT video series. Welcome, Nick. Thanks for taking some time to be here with me today.
Hey, Ryan. Appreciate it.
Absolutely. Yeah. Great conversation. Looking forward to this one. Let's start off by having you give a quick introduction about yourself and the company.
Sure. I'm Nick Sinas. I'm head of technology at Ovyl. We're located in Nashville. We are what we like to think of as a one-stop shop for product development. We have mechanical engineers, industrial engineers, firmware engineers, hardware engineers, software engineers.
Wow.
So it's a fun place to work, and we get to work on all sorts of fun and exciting projects.
Fantastic. So I know today's topic is around firmware development best practices. So I wanted to start off with the first question, just for audience who may not be as familiar, is just describe what firmware is, and then jump right into talking about the best practices when it comes to developing firmware, how people should be thinking about this process, and just what's important from your perspective.
Sure. So firmware is basically the code that runs on hardware at the lowest level. So firmware is code that interacts with buttons or LEDs or screens, or maybe is controlling an RF radio like your Bluetooth or Wi-Fi. It's usually not user-facing code. It can be, but usually it's very low-level code. And that's different from software. That's usually an application that runs on your computer or might run on your mobile phone.
Fantastic. And when we're talking about the development of firmware, who's responsible for that? Is that, obviously a company like yours, right? But if a company's out there, let's say building a IoT solution, who are they kind of usually talking to when it comes to the firmware development side of things?
Sure. So typically firmware is developed by electrical engineers or electronics engineers. It's good to have a background in electrical engineering because a lot of what firmware development involves is reading schematics or understanding schematics, being able to look at, I would say like a PCB file. So being able to understand how the electronics are made, and also being able to read and understand data sheets. So really exciting stuff. But once you are able to grasp those things, those are necessary in starting to write firmware, because firmware is so close to what is kind of called close to the metal, which is as close to your microcontroller or your CPU as possible. That you really need to understand the hardware that you're running on and that you're interfacing with.
Gotcha.
So that you can write code that's going to be more of your business logic, like, hey, we need to turn on this LED whenever this type of event might happen. In order to do that, you need to really be able to dig into the nitty gritty of electronics.
Gotcha. So when it comes to the development of firmware, can you take us through what you would define as the best practices for firmware development?
Sure. So I think there's a lot of high-level topics that you can get into when you're starting a firmware project. And I'll kind of talk about the ideal scenario. Just getting a few of these right is great. Firmware is very complicated because you're dealing with not only your code, but you have a dependency of hardware. And so that makes things exponentially more complex and harder to develop with, especially if you are developing firmware for a new product, which might be new hardware. And so you could run into problems that are specific to your hardware design, and then the firmware guy gets to blame the hardware guy. But at a high level, some best practices for firmware development would be making sure you're using good tooling. So are you using source control like Git? Are you doing pull requests and code reviews? Are your pull requests tied to user stories? Things like that are typically thought of maybe on the software side of things should be done on the firmware side of things. It's a great best practice. You need to take advantage of some of the advanced tooling that's out there. I even suggest using Docker, which is a piece of software that gives you it's kind of like a virtual machine that runs on your computer, that could be a variety of different operating systems. And Docker allows your engineers to essentially create a development environment that can be reproduced across all of your engineering teams. So you avoid that. It works on my machine, but maybe it doesn't work on your machine, which is exceptionally important with firmware because there are so many dependencies and libraries and compilers and all sorts of additional complexities when you're dealing with especially chip manufacturer code that you need to make sure is right. And those types of pieces of software or firmware, whatever you're dealing with, are notorious for disappearing. Those links just go dead online, especially if you're dealing with an older microcontroller. So it's very important that you create that development environment and kind of lock that in, and you can do that with Docker and Docker files. It was something else that came out of the software industry that I believe as firmware engineers we should embrace. Next up, I think would just be making sure that you're following a coding standard. So you can make your own or you can borrow one. We like Bar Group, their embedded C coding standard. Just a great way to make sure you're following some type of guideline and a style guide. There's some really great tools for even enforcing style guides. So if you like a particular way that all your code should be formatted, there's some great tools that automatically format your code for you that can be done on Save or on a Git hook. Okay. Some other things that I think are a little bit more advanced, but I really believe is where firmware development should move is you should be creating CI pipelines for your firmware. So it can continuous improvement, meaning your code should be able to be compiled on a server. So Docker helps with that. That allows you to make sure that the code that you're producing is reproducible. And that in your CI pipeline, you should also be running your unit test suite. So that really is a great way to make sure that, especially if you're working on a team, that if someone creates a new pull request where they're implementing a new feature, your CI server will essentially tell you whether or not you broke the build or your unit test suite failed. But it's also a good way to distribute your binaries. So you can have your CI server build your firmware file, and then everyone can go to that place to download your binary file. So you always have the most up-to-date release. It's much better than emailing out some ELF file or hex file to a whole bunch of people. So it's a complicated, it can be a complicated thing to set up, but it is worth it in the long run for sure. I think another thing that's very important is making sure if you are working on a lot of projects that you are starting to template your project. So if you jump into project A, that is, maybe one piece of firmware for a product, and then you're jumping over project B, that they look very similar. You're organizing your code properly. We like to, in our code repos, at the root level, that you have a source file, a vendor file, a source directory, a vendor directory, docs directory. And it's like that across all of our projects. So it's very familiar, and everyone's kind of following that same best practices. I would also suggest making sure you put data sheets and schematics, if you need them, in your source code repository, because data sheet links can just also disappear, or they get versioned and you lose the old version for the part that you have. So let's see. Other than that, I would say really focusing on automation and testing. So developing a good unit test suite. You can even go as far as implementing a shell or a CLI in your firmware so that you can interact with your devices through a UART or a USB cable. So you can essentially command your device to do something that maybe normally would take hours for it to happen normally. Like, let's say you connect to your Wi-Fi router to upload some sensor data, once a day to save battery. Well, if you're developing firmware and you need to do a whole bunch of stuff quickly to test out those interactions, you don't want to wait that amount of time. You also don't want to necessarily build in a whole bunch of random pound if define, I'm developing, do this interval. If you have a CLI where you can say, hey, do this right now, it really makes your life a lot easier, makes developing firmware a lot easier and faster. But it also allows you to move into automation to where maybe you need to automate 2 or 3 devices that need to talk to each other. If you're dealing with Bluetooth, you could command your Bluetooth peripheral to connect to your Bluetooth central and send some payloads over, and then pull both of those payloads out and make sure that everything worked properly. So it gets to that integration testing that's also extremely important for developing devices and firmware development. Just because it works on one device doesn't necessarily mean that it works on both devices.
Sure.
And that kind of goes into another best practice, which is trying to make sure you're writing common code. So a lot of companies tend to make a mono repo where they have, both. If they have 2 devices, they'll put both of those code repos or code repositories all in one repo. We don't really like that because it makes PRs very difficult and complex. And so we shy away from that and really say, look, if you have common code that needs to be shared across 2 different products, make a dedicated repo for your business logic or your common code, and then share those across projects as a Git submodule. There's downsides to that, but I think it's really the best path in terms of making sure you're not just copying a bunch of business logic across 2 different projects, while also allowing you to keep your individual repositories clean and allowing for good pull requests and code reviews. Security is very important. A good best practice to stay up to date on security issues and security best practices. So things like, are you communicating over encrypted transport? So are you using TLS? Are you storing any sensitive information in non-secure flash? That's not good. So find the secure storage element on your microcontroller if you have one, or add one, and make sure that anything sensitive is being stored in an encrypted way, so people can't reverse engineer out sensitive information like, oh, this is your API key, and oh, you just use the same API key across all of your devices. Well, now I've got it, and now I can talk to your API. Another thing that we see is a lot of IoT devices use MQTT, which is a particular publication pub sub protocol. AWS IoT and Azure IoT Hub support this. I think Google Cloud has that as well. But security-wise, they use certificates and private keys for each device. We've seen several products reuse that same private key and a certificate across like all devices, which is really a no-no. You want to make sure that all of them are unique and communicating in a secure way. And And then making sure that if you do support firmware updates over the air, or firmware updates in an automated upload or update, that you are using signed firmware images. So making sure you're not just accepting anybody's firmware image if someone gets a hold of it and wants to put in their own code. Yeah, I mean, security is one of those things that firmware engineers just really need to stay on top of, especially now. There's laws getting passed around cybersecurity for IoT devices. And so it's very hard to stay on top of that and understand what that means for a firmware developer. So making sure that you're reading about that and implementing that in your project, and keeping that in mind when you're planning a project out or you're quoting a project is also important. That, hey, maybe we need to get this device tested, or there needs to be some penetration testing or some reverse engineering testing, or some type of security review. It's becoming more and more important as a best practice for firmware development.
Absolutely.
I think after that, it's making sure you have good requirements. But that's very, very hard to do, depending on who's writing and providing those requirements. But just making sure you know what you're working on, you're not wasting time, and then you have a good system for tracking that. So if you use, we like GitHub issues. I mean, it's simple enough for just writing some user stories and tracking those to a PR. Don't need to overcomplicate it. And then for documentation, making sure that you are documenting your code with good comments, but also Doxygen is a great tool for automatically generating documentation based off of those comments. It's a great tool, but it doesn't necessarily tell you if your logic is right. And so we like to, inside of the same repo, create markdown files that documents how the device should work. And Mermaid is a great tool for generating flowcharts in code. So ideally what you're getting when you open up one of our projects is you see your documentation of how the device is supposed to work. You've got all the data sheets and schematics in there, and then your source code and your unit test suite. That's kind of your best picture in terms of best practices in our mind. I think the last thing to maybe talk about in terms of just making firmware developers' lives easier would be to harp on the hardware developers, making sure that they are designing hardware that's going to make your life easier. So, hey, do I have a UART or two for talking to this device? Can I get some extra GPIO for debugging? Or can you slap a couple LEDs on there so that I can just turn this thing red if it ever goes into a particular error condition, or some type of LED sequence on startup, so I know oh, it's sitting across the room and it just reset. That's not good. Good silk screen on your hardware to very readable test points on all your comm lines. So if you're talking to something over SPI or I2C, making sure you have test points on all of those for a logic analyzer is very important. You don't want to have to be trying to put tiny little grabbers on very small pins. Good revision control. We use Altium 365. That way we can share our schematics and board files with the whole team. I think the last thing would just be that you convince the hardware engineer to, it depends on the hardware that you're developing, but if you're, especially for low power applications, if you got a battery powered device that maybe has multiple radios or multiple major components on them, that you have them add test points or jumpers in a way where you can individually test the current draw of those major components, so that you can try and figure out what's drawing too much current here that maybe I'm not expecting. And that's super helpful when you're debugging. Hey, I should be drawing 4 microamps and I'm drawing 40 milliamps. What's happening here? This is not good. And by individually being able to test those major components, it really makes your life easier when you're debugging low power, battery powered, or low power and battery powered applications. So
fantastic.
Yeah, sorry, that was really long time.
No, it
I
was
feel like
it
that's
was such a good
maybe
it was such a good list. Like, I know when we were initially going into this recording to, like, talk about it, there really was an expectation on what the length of the list would be, but you just kept rolling, and I did not wanna cut it off because each new piece was almost like a lot of them were questions I was gonna ask as a follow-up, like, "What about testing? What about security?" And you just kept hitting them. So, no, I was just
I
gonna
was
sit
reading your
back and let
mind.
you I was gonna sit back and let you keep going because this was a fantastic list. I think there's gonna be a lot of value, and especially for those teams that are looking to better understand how to do this successfully. So, last thing I want to ask you before we jump off here is for our audience who wants to follow up to this kind of conversation, this episode itself, maybe ask questions, learn more about what you have going on over there. What's the best way they can do that?
Sure. You can reach out to us through our website, or I'm on Twitter at Nick Sinas, or our company's on Twitter, Ovyl
Okay,
Studio. LinkedIn is also good. You can hit me up on LinkedIn or our company up
cool.
on LinkedIn. We're pretty responsive.
Awesome. Well, Nick, thanks so much for your time today. It's been great talking to you. And I think our audience is going to get a ton of value out of this one.
Appreciate it, Ryan. Thank you for having me.
All right, everyone. Thanks again for watching that episode of the Ask IoT video series. I hope you found a lot of value in it. If you did, please be sure to like the video and subscribe to the channel. It helps others find it and make sure that you get the latest episodes as soon as they become available. Other than that, if you have any questions or topics that you would like us to cover in this series, please leave them in the comments or shoot us an email at hello@iotforall.com. Other than that, thanks again for listening, and we'll see you next time.